Hi, this video is for converting fractions. So we're going to be looking at improper fractions and mixed fractions, and then I'll also go a little bit into converting fractions to decimals. So hopefully this will help you as you work on changing numbers. So this can really be useful as you work on homework. Some of the software programs want you to express your answer a certain way. So let's say you've solved an equation, or you've multiplied fractions or something, and you've come up with a solution, but the the homework program is saying that it's wrong, and maybe you're 100% positive that it's right. It might simply just be that you have it in the wrong form. So this is going to help you convert your fractions into the correct form depending on what it asked for. So sometimes your answer will be expressed as an improper fraction. And an improper fraction is larger in the numerator than the denominator. So basically what this is saying is that the top is larger than the bottom. Numerator is the top, denominator is the bottom. So I usually remember that denominator is down, denominator is in the bottom. And when the top is larger, when the numerator is larger, we call that improper. Oftentimes it's useful to convert an improper fraction to a mixed fraction. You might also see this as mixed number. So it gives us kind of a better idea of what that number looks like. And a lot of times in your algebra-based classes, they want these fractions expressed differently. So that's where you're going to see this. Once you get into like calculus and trig, they'll usually let you leave it as an improper fraction. But for the lower level classes, we want that as a mixed fraction or a mixed number. And a mixed number kind of looks like, has this big fonted number and then the fraction to the side. And you read that like, for example, 2 and 3/4 or 3 and 1/3. And it is one number, it's just a mixed number, which means it's got that whole number piece and then, or an integer piece, and then the fraction part together. And these are actually joined by addition. You probably won't see it this way, but it's actually a little plus sign in there. You'll probably never see it written that way, but there's a common misconception that those two numbers are being multiplied because they're side by side. But that 2 and means that there's like an extra little piece being added into it. So let's get into converting these fractions. Our first example, we have 9/7. So if we can get a better idea of what that is, I could draw you a picture and you could kind of see what that looks like. Sevenths. I don't really want to draw sevenths. Let's start with let's be a little spontaneous here. Let's start with number 3 because that's going to be a little bit easier to draw. Same exact concept, but the fourths is going to be easier for me to illustrate for you. I'm not great at drawing, so fourths are easy. I'm going to draw some circles. 1, 2, 3, 4, 5, 6. Pretend like they're the same size. This one got a little bit smaller. We could fix it. Okay. It got worse. So hopefully I fixed it. They're still all different sizes, but you'll get the idea in a second. I'm going to draw fourths. I'm going to try at least. Like I said, I'm no artist, but you don't have to be an artist to understand math. It can help, especially if your sections are the same size. It's all right. If I were to color in 21/4, then that would look like, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then I need one more. So this is a picture of 21/4. We're counting out 21 of the 1/4 pieces. Now, if we look at these, if we count the units that are shaded in, there's 1, 2, 3, 4, 5 complete shaded pieces. And then the last piece represents 1/4 that's shaded. So this will be written 5 1/4. So if you're a picture type person, that's how you can envision it, 21/4. If you're more like me and you want to see that mathematically or algebraically, what you're going to do is 21 divided by 4. And how I got that was, this is 21 divided by 4. So what you're going to do is actually divide it. 4 goes into 21 5 times. And we have one piece left over. So there is that 5 1/4. We took the 5 pieces, 5 whole units, and then this formed our remainder. And you can hopefully see how that relates to this picture. Pretty cool, right? So on this one, I mentioned earlier that I really didn't want to draw sevenths. That's really hard to do, especially with my skills. So on this one, I'm actually just going to divide it. 9 divided by 7. And if you're getting confused as to where the 9 goes and where the 7 goes when you're writing that, this is 9 divided by 7. So you can also write that 9 divided by 7. And so what's happening is we have top divided by bottom. And so 7 goes into 9 one time with 2 left over. So if you can picture a drawing, you would have one whole circle shaded in and then 2 little pieces remaining. So that's kind of the remainder. I almost asked questions because I'm in the habit of asking that when I'm teaching class. So if you do have questions, you can comment below and I will get a notification and I'll answer them as quickly as I can. Okay, at this point, I want you to pause the video and try this one on your own. When you're done, unpause the video. I guess hit play would be unpause. Hit play and see if you got the right answer. So I'm going to give you a second, pause it, and then come back. So hopefully you've tried this on your own. We have 19 divided by 6. It goes 3 times with 1 left over. And that's your answer, 3 1/6. Last one, again, pause it, try it, and come back and see if you got the right answer. You should get, it goes once, that goes 8 times. We're getting a lesson in division here. So we have 18 2/3. That kind of looks funny. So this one would have been a little bit hard to draw because 18, we would have had to draw 19 circles. So I wouldn't want to do that. So this is kind of why I lean towards this method over drawing. But I will say that the more drawings you do by hand, the more you'll be able to envision it in your mind. So instead of having to draw it out every time, you can kind of see it in your mind and go, oh, that's going to be 18 circles with 2/3 left over. And that stems from this division that we're doing on this page. One of the things that's not in the notes that I do want to go over, sometimes you might be asked to express a fraction as a decimal instead, or maybe a decimal makes a little bit more sense to the problem. So if you're asked to convert to a decimal, we're still going to be using that process of dividing. So let's just look at an example, an easy one, 1/4. And what you're going to do is you're still going to do top divided by bottom. 4 does not go into 1. So we're going to add a 0 here, and we're going to bring that decimal up. 4 does go into 10 2 times. And then we're going to add another 0 here, bring it down. 4 goes into 25 times evenly. And so this is the decimal representation of 1/4. And then if you had another example would be 3/4. Go ahead and pause it and try it. See if you get the right answer and then come back. If you've tried it, you should have 3 divided by 4. 4 is not going to go into 3, so we're going to put a little decimal here. It goes 7 times. We need to pull down another 0. So you should have gotten 0.75. So that's how you do that. So let's go further into the notes here. We are going to be given a mixed number or a mixed fraction, and we're going to be asked to convert it to an improper fraction. So we're going to be reversing, flip-flopping. So we know that a mixed number is in this form, has the larger, it has that integer piece and then the fraction piece. And we can convert it to an improper fraction. I call it a C or a circle. I've heard it called about Texas. I don't know where that came from, but some of my students have said it. So if you've heard of that, that's what that is. And this is kind of a poor drawing of it, but basically what you're doing is if we've got this mixed number, you're starting down here and you're working your way around. You're going to multiply the denominator times the big number, and then you're going to add that top piece. And what that's coming from is when we did divide, like here, it went 5 times with 1 left over out of 4. So what's happening is we're using the, I think it's the quotient. Oh, I can't remember the name. I'll have to look it up. I'll look it up in a second. But basically what's happening is we did 4 times 5, and then we're adding the remainder piece to get that total amount. I have to look that up. I'll look that up. That's going to bother me. Okay, so I know where it comes from. I had to Google the words. I knew what it was. I knew what it looked like, but I couldn't remember the words. This comes from the division algorithm. And I'll spare you the details, but if you want to look that up, you can. It's pretty cool, but that's kind of where this comes from. So we do C times A plus B over the denominator. And it's a lot simpler than it seems. So we have an example here, 2 3/4. We're going to do this little C. So we do 4 times 2 plus 3 gives us 11 over our denominator. And then if we were to draw a picture of that, oops, I'm going to fix that. I know I'm going to need 3 circles. And then 11/4 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's where that's how it's related to that 2 3/4. So that's the picture form of it. And then the division algorithm says that we take that, the denominator, the divisor, divisor. Anyway, I can't remember the words. Words escape me. I like math. Again, that bothers me. So I looked it up. If you're curious, this is the divisor. So I was right. This is the quotient, dividend, and then the remainder. So all those words, doesn't matter. I digress. I like to chase rabbits, apparently. All right, so let's try this one, 5 1/3. If you want to pause it and attempt it and then come back, please feel free to do that. It's really good practice. It's a good way to kind of check yourself to make sure that you're on the right track. So pause it, try it, come back. Once you come back, you should have gotten 5 times 3 plus 1 is 16/3. Okay, next one. This one's a little bit different because we have this negative out front. But we're gonna kind of ignore the negative while we do our converting. 4 times 1 plus 3 is 7/4, but we are going to put it in our answer because it is negative. The fraction is negative. So you can put this negative in the numerator, or you can kind of put it out front. And either way is okay. They mean the same thing. I'm used to just putting it with the numerator, but it really doesn't matter. They mean the exact same thing. And then the last one, go ahead and try this one. Pause it, come back. And you should get 12 plus 2 is 14/3, and it is negative. So if you were given another little rabbit we can chase here, if you're given a mixed number and you're asked to convert it to a decimal, there's several ways you can do that. For example, 1 1/4. What you can do is you can convert just the fraction piece, which we've already done in this lesson, and that becomes your decimal. Or you can convert this fraction to an improper fraction and then do your division like we did on the previous page. So there's two ways to do that. Anyway, you get the drift there. But that's all I have for this lesson. I hope you enjoyed it. Sorry about all the rabbits I chased. Hopefully it opened your mind to a few new possibilities. If you need any help, please reach out and I would be happy to assist you. That's all for this one.